So today I'm going to take you through graphing sine and cosine functions and then a little bit with the transformations of those functions. You say, what do you mean graphing sine and cosine values? Well, if you think about the function y equals the sine of x, here we can actually make an xy chart for an input for x and an output for y. And then we can start to plot those points. And when we do, we get a graph. So that's what I mean by graphing sine and cosine values. Later on we'll do tangent, and we can do all the reciprocal trig functions with that as well. So how do we get these x and y values? What's the domain of the function? What's the range of the function? Those are things we have to think about. So the first thing to think about it is, what is our domain? So if you just do a quick sketch of the unit circle, we know the one that we've mainly talked about goes from 0 all the way around to 2 pi. But remember when we talked about coterminal angles, we can have angles greater than 360 degrees or greater than 2 pi radians. And so you can go around the circle again. So twice around the circle, remember, is 4 pi. That angle right there. And you go around the angle again. In fact, you can pick any angle on the unit circle, like say you got pi over 2, and you can come up with a coterminal angle for it by adding 2 pi to it. So pi over 2 plus 2 pi, that's the same thing as 4 pi over 2. Just getting the denominator the same there. And we get 5 pi over 2. Now what's special about that is, well, think about what the sine value, if I put pi over 2 in for x, I know the sine is my y distance, or 1. The same is true about 5 pi over 2. If I put 5 pi over 2 into that function, the sine of 5 pi over 2 is also 1. And so these values will repeat themselves going around the circle, but it tells us that our domain there can include anything between 0 and 2 pi, but also multiples of 2 pi being added onto it. Likewise, in the negative direction, we could go a negative 2 pi or a negative 4 pi around the circle. And so you can keep going in the negative direction as well. You're just spinning that ray there actually not counterclockwise, you're spinning it clockwise. So our domain is going to be all numbers there. And so it's also important to note that we're talking about all this stuff in radians. And if you're graphing it on one of those old TID3 graphing calculators, you have to put it in radian mode, because it makes no sense to input 30 degrees into these. There's no way on your x-axis you're going to find 30 degrees. So to start us off, let's first draw an x and a y-axis. So because I'm used to graphing these things, I know that for this, I'm just sketching it out. I don't need a y-axis quite as tall as my x-axis right here. And then I'm just going to plot the points there on the unit circle first, and actually only a few of those. So I'm going to start at 0 on my x-axis, and I'm going to go to one full trip around the unit circle, which is 2 pi. So I'm just going to have my sketch of my unit circle right here. I know going all the way around the circle is 2 pi. Going halfway around, we land at pi. So halfway between 0 and 2 pi is pi. So if I'm actually measuring this out on the x-axis, this is at close to 3.14. This is close to 6.28. Notice we can't do that with degrees. Where's 30 degrees out to the right? That doesn't make any sense. But 0 and pi and 2 pi we can actually look at as distances, because we're talking about the arc length going around the circle there. It is a distance going around. So then I'm going to go halfway between 0 and pi, and that gives me pi over 2. That's where this angle right here is on the unit circle at the very top. And then I've got 3 pi over 2. It's halfway between pi and 2 pi. Now, something that's going to be helpful for later on, these we've got all memorized. Later on, we're going to have some that aren't so convenient on the unit circle. To come up with this angle, I'm just going to average this one and this one. I'm coming halfway between them. So 0 plus pi divided by 2 gives me pi over 2. To come up with this point, I'm averaging this one and this one. Pi plus 2 pi is 3 pi. Divided by 2 is going to be halfway between those two. That'll be useful later on when we do transformations. So let's go through and just plot these points. I've got it marked in degrees here just to kind of get you familiar with how big these angles in radians are. But really, we don't need to pay much attention to the degrees because everything we're going to do is in radians. So as our x input goes in for 0, pi over 2, pi, 3 pi over 2, and 2 pi, I want you to put it into this function right here. Y equals the sine of x. Put your x values in, find your y values using your unit circle, pause the video, and complete that chart. So if you're having a hard time completing that chart, remember that our sine value is our vertical distance going around the unit circle. So right here at 0, the vertical distance is 0. Right here at pi over 2, the vertical distance is 1. At pi, it's at 0 again. At 3 pi over 2, which is right here, we're at, from the origin, -1. And at 2 pi, we're back at 0. So those are the points that I'm going to plot here. At 0, we're at 0. And notice our max and our min here. We're going all the way down to a -1, and our max is at a +1. So our max and our min here with sine and cosine here, we're really talking about what we call the amplitude of it. The amplitude is 1. You're 1 away from the x-axis. So anyway, plot these points 0, 0, pi over 2, we're back up at 1. At pi, we're at 0. At 3 pi over 2, we're at -1. And then at 2 pi, we're back to 0. So this is what we call one complete period. And the reason why we call it one complete period is because remember a second ago, we could actually continue this on all the way out to 4 pi or 6 pi or 8 pi and so forth. And it's going to repeat this pattern right here, this wave looking like pattern. If you're in physics, you'll see this a whole bunch on any type of periodic motion. And most of the time, you can relate periodic motion back to some type of sine or cosine curve. So right now, what I want you to do is take a pause from this, and you don't have to actually pause the video, but pause it, go to Desmos, and I'm going to take you to Desmos as well and work through the next example with me. So once you go to Desmos, I want you to click on Start Graphing, and this screen will come up. I think my recording screen has kind of cropped this a little bit, so you may not see all the tools on my screen that you have on yours. But the main thing is to get this started. Notice we're going from 0 to 2 to 4 to 6, which is fine when we go to graph things. But I want to make sure that I can graph trig on here easily and see my x-axis like we just graphed a second ago. So I want you to go over to where the little wrench icon up here is, see where it says graph settings, and click on that. And then currently it says the x-axis goes from -10 to 9.8 or whatever. If you change this step right here, and if you just go to type in it and you type pi, type that. So let's see. If you pull up the keyboard, you'll see these tools here. Once again, off the screen down below over here, I've got the symbol for pi. Or you can just type in pi if you've got a keyboard there, and it will show up as well. But notice as soon as I'll go back, as soon as I type in pi, it changes the scale down here on the x-axis for me. And so now that's looking a little bit closer to what we seen a second ago. And you can even change it right here. You can make it go from like -pi to, I don't know, 4 pi. And then that way you kind of see a little bit closer. Let's take it down to 2 pi. And now you'll see it even closer there. So let's click out of that now. And as you drag and you zoom, those things are going to change anyway. You're going to see more divisions on your x-axis. So it's not going to look exactly like we had it a second ago where it goes from 0 to 2 pi. We could change that probably even more if I can get this to cooperate. Let's see, if we go down to our step, instead of stepping it by pi's, we could probably step it by pi over 2. And now we can see it more like what we saw in my graph a second ago. We have 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Now it's going from 2, whoops, my pen acts kind of funny when I hold it up near the screen. Now it's going from 0 to 5. A second ago it's going from 0 to 2. Yeah, Desmos doesn't like this pen I use to make these videos. Just found that out. But anyway, we could change that as well. If you go to settings, and change this to go from, say, 0 to 3, or let's actually have negative values in there. We'll go from -2 to 2. Now we can see a little bit more of what's going on when we type in something like sine of x. So let's do that. Let's type in sine of x. So I'm just going up here to this entry key here and typing in sine of x. And there we go. You can type in y equals, you type in f of x equals like we've done before. Now notice on this, it's exactly like we had it before. It goes from 0 to 1 to pi to 3 pi over 2, and then 2 pi. The values in between should match up as well. So we talked about before, like, what is the value of sine at pi over 4? Well, it's the square root of 2 over 2. So if you actually go to pi over 4, it should be halfway between 0 and pi over 2. You should get something equivalent to square root of 2 over 2, which I think we said before was around 0.7, somewhere in there. And so all those values we could go around the unit circle and plot out. But really, once you get used to graphing these, if you plot this, these main 5 points here, 1, 2, 3, 4, 5, you start to realize the pattern and know it makes that curve going through it. If we zoom out, notice this thing goes on forever like this. But as we talk about it, remember all the things, important things we talk about functions before. What's its domain? Its domain is all real numbers. What's its range? Now this one, the range bounces between what? It bounces between -1. Whoops, it does not like my cursor here. It bounces between -1 and 1. So it never goes beyond -1 and 1. That's an important thing that we'll see in the future there. Unless there's a transformation done to the sine function, it's going to stay between -1 and 1 there. And so that's the basic sine graph there. Let's take a look at the cosine graph. Now, as we do these, I want you, and with the homework assignment when we do transformations, I want you to try out whatever transformation I got, whatever function I've got for you. Try to figure out what the period is, try to figure out what transformations are going on, what the graph looks like, and then come into Desmos and check it. All right, remember Desmos isn't, a cheat or an easy way to figure out how to do your homework. It's a way to check your homework so you know that you got it right. You can explore things more in Desmos, and hopefully you'll come out with a better understanding of how Desmos works. Not Desmos, how trig works in graphing, and Desmos also. All right, so now I want you to try to do the cosine. Cosine is going to be done in a similar fashion. We've got our x and y axis again. You're going to go ahead and fill out this chart right here. So pause the video, fill out that chart. All right, I'm assuming you've done that. If you haven't, follow along here. Remember, going back to the unit circle, cosine is our x distance. So looking at where 0 is, the cosine of 0 is going to be the x distance from here to there, which is 1. Pi over 2 at the top of the circle, cosine is 0, or x distance is 0 to get to this point. For pi, we're at -1. For 3 pi over 2 down here, we're at 0 again. For 2 pi, we're at +1. And so, once again, I'm going to mark out these points. Here's 0, here's 2 pi. Halfway between 0 and 2 pi is just adding up those two numbers and dividing by 2. That gives me pi. Halfway between 0 and pi is just adding up those two numbers and dividing by 2. Halfway between pi and 2 pi. Adding up the two numbers, I get 3 pi. Dividing by 2 gives me 3 pi over 2. Then once again, looking at these, notice my y values bounce between 1 and -1. So amplitude of this function is just 1. This is y equals the cosine of x. And then plot my points. So at 0, my y value is 1. At pi over 2, I'm down at 0. At pi, I'm at -1. 3 pi over 2, I'm back at 0. And 2 pi, I'm back at 1. And so this curve looks like a bird, right? No, it goes on forever. So really, we're pi over 2 right here, somewhere at -pi over 2. That's not really to scale because I don't have enough room over here. It's going to be coming back down to right there. Somewhere at pi over 2 past 2 pi, it's going to be coming back down to 0 there. So, travel over to Desmos. Actually, before we go to Desmos, let's just compare this to sine. Go back and look at sine. And we know it keeps going on forever like this. And then look at cosine. You know, there's not a whole lot. Let's see if we can do something like this. Let's take this line and copy it. And let's paste it over here. Edit. Paste. And we move it in where it goes. Pretend like it needs to go over. I drew the scale a little bit different. There's close to what we had on the other screen there. Pretend like that goes to 2 pi. And notice they're pretty much the same shape. In fact, we're going to graph them right on top of each other in Desmos in a second. And we're going to see it's just a small shift between sine and cosine. So go to Desmos now. So here we are at Desmos again. I still got the sine graph up. I'm going to go ahead and graph cosine here. So cosine of x. Boom. There it is. That looks a little bit better than what I had on the other screen. Now, if you just want to see cosine, we can turn off sine by clicking on this. There's our cosine graph. Hello, zoom in. There we go. And we can see how it has that bird shape between 0. Where did it go? Between 0 and 2 pi there. It's got that bird shape, but it's not really a bird shape. It goes on forever, zigzagging back and forth like that. So it's just a small shift from sine. Let's turn back sine on. And you can see how similar they are. That's why I said any type of periodic motion we can relate to as sine or cosine, because I can, with some transformations, I can take this blue graph and shift it to the right by pi over 2. And by doing that, then it's going to be on top of it. In fact, let's try that out. What type of transformation would shift the blue graph, that would be cosine there, to the right pi over 2? So as we think about that, because it's going to lead us into some things we're going to be talking about here in a moment, think about, let's go with y equals x squared. Now, I know if I put plus 3 right here, it would take this graph of y equals x squared at the origin and shift it up 3. So that would be a vertical shift. And likewise, if I took y equals the cosine of x and put plus 3 on the outside, our normal graph goes through the x-axis and bounces between 1 and -1. We're going to see in a moment, when I do something like this, add 3 to it, it's going to take this horizontal line right here, which is our our x-axis, and it's going to shift it up 3. So it's going to be up 1, 2, 3. Let's move this thing over out of our way. Well, cosine stuck with it, so let's just erase it. And we have room to graph. So y equals cosine of x plus 3. It's going to shift it up to this line right here. That's where this line was. And it's still going to bounce between 1 and -1, but not really 1 and -1. It's going to shift 1 up to 3, which is going to be at 4. It's going to bounce between 4 and shift this one up 3. 1, 2, 3, 2. So that's a vertical shift though, and it's going to go from here to here, back down and up. It's going to look like that right there. That's just adding 3. We'll do that on graph paper so it looks a little bit better than my sketch there. If I want to shift x squared though, the parent function x squared, to the right 3, think about what that would be. It would have to be paired with the x and -3 right there. That would shift this thing to the right 3. And so same thing here, if I had y equals the cosine of x minus 3, that would shift it to the right 3. But I don't want to shift it to the right 3, I want to shift it over pi over 2 to the right. So it'd be y equals the cosine of x what? I heard somebody say it, x minus pi over 2. Let's go to Desmos and check that. So if I took this cosine right here, put some parentheses around the thing, and said minus, where's my minus sign on this? I'm kind of using like a tablet thingy here to do this, so keyboard isn't there with me. Minus pi divided by 2. Too many parentheses going on. Parenthesis, parenthesis, parenthesis. There we go. I don't need all those parentheses, but it looks cool, right? So anyway, notice if I turn off the red here, the blue is right behind it. So I've got both of these functions are graphed the same way, or they're the same. The graph is on top of each other, even though they're being represented by two different functions. So keep that in mind. Sine and cosine are just a shift away from each other. Now what I want you to do is consider if we made this pi, the number in front of that pi, like a 3. How would that change the shift? Well, now it's going to be shifted over 3 pi over 2. And so if we compare this to, let's go back to the regular old cosine of x. Notice the change there. Is it any different than sine of x? There's the sine of x. It's starting to look kind of cool, doesn't it? Like a spiral graph or something like that. So it's different than sine. It's different than cosine. The cosine of x minus 3 pi over 2 is taking this purple graph right here and shifting it to the right 3 pi over 2. And that gives us the blue graph there. And so if we were to change this value to, say, 4 pi over 2, well, that's the same thing as shifting it. I'm just changing that number in the numerator because it's convenient. That's the same thing as shifting it to the right 2 pi. And notice now it does kind of line up a little bit there with the purple. See, there's our purple graph of cosine of x. So it lands right back on cosine, which should make sense because you're shifting the whole thing to the right 2 pi. So it doesn't really change it that much there. But if we were to go through and let's make that a slider now. And now we can go through and see how just by dragging that value right there, we can shift it to the right or the left depending on which way it goes. If we take it in the negative realm, it's like saying a plus right here. So you're shifting it to the left. But we can see how that works. Now, if I turn off all the rest of these, go away, turn off. Sorry, that's my son there. Oops, he's going to start crying. Hold on one moment. Okay, I think I got him settled down. I've got a newborn in the house, so I'm doing these videos while doing the third shift with him. As we slide this back and forth, we can see the transformation going on. And so normally we start the graph, we think about starting graphing sine and cosine right there at 0, but when we shift it to the right or the left, and it doesn't fall in a convenient spot on the 0, like whatever that value is, we might want to start right here at pi over 5 and go one complete period, and so here we start going down and then up, and then we pass right back through right here. The period would go from pi over 5 to 11 pi over 5. So it's still 2 pi completely, but this is where we'd start and end, or we might start back over in here. What I'm looking for in my class is you to graph one complete period. And so what I mean by that is you have these little maximums here, and then you got these minimums, and you got the ones right here in the middle. So you can go from a crest, is what we call that, to a crest, or a valley to a valley. It's like hills and valleys here. Or one start point to the next. Just be careful with that you graph a complete cycle. But what I mean by that is if you're thinking about like graphing starting right here, you're starting right here in the middle and you're going down to the minimum, and then you go back through the x-axis. Don't stop there though. Go all the way back up. When does it start to repeat itself? Oh, when you're in the middle and you start going down again. So I want you to graph it until it starts to repeat itself. That's what I want to see on the graph. I'm also looking for the points in between, like what that start point is, pi over 5, what this bottom point is, in this case 7 pi over 10, what this point is 6 pi over 5, this point 7 pi over 10. This is a little bit of a ridiculous example, and then 11 pi over 5. But we're going to do a bunch of these, so you're going to get used to what I'm expecting and what I'm looking for here. Just know that it doesn't always start at a convenient y value when you're at 0 there. So the first, we looked a little bit about shifting to the right or left. I've got an easier way to do that than just to go through and shift all your points over pi over 2 or 3 pi over 12, whatever I'm giving you, pi over 4, whatever. And we'll talk about that in a moment. Right now, I want to look at this type of transformation right here. If we have y equals 1/2 cosine x. First, before you even try it out, predict what it would look like. Think back to something like one of your parent functions you learned before, like y equals x squared. We know y equals x squared looks like this. What does putting a 1/2 right there in front of it do? What does putting a 5 right there do to it? So think about, is it a vertical shrink? Is it a vertical compression? In this case, it's a compression because you're making all of your y values half as big as they would have been. So they're being compressed. And so let's look and see what happens here when we start substituting in. We still got the same chart from the last slide, but now we're going to take our y value, which is cosine of x, and we're going to change it to half of cosine of x. So we're just going to take this value and times it by 1/2. So we get 1/2, 0, negative 1/2, 0, 1/2. And so when we go to graph this thing, that's the points we're going to plot. We're going to go from 0 to 2 pi. Half of 0 to 2 pi is pi. Halfway between 0 and pi is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. Now this time, notice our numbers are bouncing not between negative 1 and 1, but they're going to bounce between negative 1/2, that's a negative 1/2, and positive 1/2. But everything else looks the same. And so at 0, we're at 0 right here. Here's 0. No, sorry. I'm looking at my y value there. These are no longer important. At 0, we're at 1/2. And then we go to pi over 2 at 0. Pi, we're at negative. Not right there. We're right here at negative 1/2. Then back up to 0. And then at positive 1/2 here. And really, if you look at the two graphs between this one and this one, not right there. Where am I? And their cosine we did a minute ago. They look exactly the same when I sketch them out. The only difference is it's right here, what I'm putting in for my y value. And so guess what? That's one of the things I'm looking for when I go to grade this thing. If you put negative 1 and 1 here, you're going to be wrong. But if you put negative 1/2 to 1/2, it looks exactly the same. Because for all I know, that's the way you scaled it. You can draw 1 down here, and negative 1 and 1 if you want, and go to the halfway mark. But that's what I'm looking for. So this value right here is what affects the amplitude at 1/2. And so if we were to change that to say, let's see if we've got a different number here. Not horizontal shrinking yet. We don't want that. Let's see. Let's just make up our own. If we had something like y equals 5 times the cosine of x, everything stays the same. We're going to have 2 pi, pi over 2. I hear some of you whining again out there. Put a passy in it. There we go. Put the passy in. He spits it back out. Okay. Then we've got 3 pi over 2 right here. We know the cosine of 0 is 1. So this right here is equal to 1. And 1 times 5 is 5. So at 0, we're going to be at 5. We know the cosine of pi over 2 is 0. So this would become 0. 0 times 5 is 0. The cosine of pi is negative 1, so negative 1 times 5 would give me a negative 5 right here. Then it bounces up. So I always kind of say, if I know I start here, I go down, down, bounce back up, down, down, and it kind of follows that pattern there. Looks just the same as the others. This number is what changes these numbers right here. So it goes from 5 to negative 5 now. Now, if the whole thing had like a plus 3 on the end, then we know the whole thing shifts up 3. And so that would become an 8, and this would become a -2. All right, you try graphing this one now. Y equals 2 times the sine of x minus 4. So just draw you like a y and x axis again. Pause the video and give it a try. So the way I work this is first I say, okay, I'm going to go from 0 to 2 pi. There's no change in that because it's just x in the parentheses. When it's not just x in the parentheses, there's probably going to be a change between 0 and 2 pi. We'll talk about that in a moment. No, we'll do it in a moment. The rest of it, we're just going to say add the two numbers on the end, divide by 2, gives us pi. 0 plus pi divided by 2 gives me pi over 2. This is 3 pi over 2 again. Now, I recognize, hey, there's a change in amplitude. Instead of going between 0 and 1, it's going to be going between 0 and 2 and 0 and -2. If that were the case, that was all it was. If I covered up this -4 right here, it would just be graphed through here like so. We know that the sine of 0 is 0, and then we'd go up, down, down, up, and that would be our graph. But the -4 tells me to shift everything down 4. And so when I shift everything down 4, let's do that. Where the 0 is now going to be at -4. So I just kind of draw a dashed line in right here to say, hey, that's the horizontal part. And then where this +2 is, if you shift it down 4, it's going to be at -2. And where the -2 was, it's going to be at, subtract 4 from that, at -6. So everything got shifted down 4 based on that transformation. And then I'm going to go through and say, okay, normally the sine of 0 is 0, and so that's where this point's going to be. And then I'm going to go up to the middle, down, back up to the middle, and notice here's where it starts to repeat itself, so I can stop there. And then draw your nice, well, that wasn't so nice, smooth curve. There we go. And so as we look at this, the amplitude is still 2, because the amplitude is the absolute value from here to here. And that value is still 2. Or you could say it's the absolute value from here to here. Between -4 and -6, the value is still 2. And so that's what we're seeing. Whoops, not moving that around. That's what we're seeing when we look at this right here. This is our amplitude. And so that's the distance from the max to the middle of the graph there, or the min to the middle of the graph. This is our vertical shift. Just like we've seen on other parent function transformations before. In here is where we have things called like a phase shift, which we'll see here in a moment. So all these, as you go through them, you can check them on Desmos. Make sure you're doing that because sometimes they can be a little tricky, especially as I add more and more different types of transformations to it. So let's look at another one here. Let's do y equals the sine of x plus, let's do pi over 3. So for this one, we're going to set up our XY chart. And you already know this is going to be a phase shift. Which way is it going to go? It's going to go to the left. Because remember, if we have something like, I'm still in the line tool here. If we have something like y equals, forget that, x minus 4 squared, this is shifting it to the right 4. If it's a plus 4, it's going to be shifting it to the left 4. I know this is going to shift everything to the left pi over 3. So when I sketch out my graph, I'm going to leave a little bit of room here to shift it to the left. Now normally when we graph sine, we go from 0 all the way over to 2 pi. But everything's being shifted to the left pi over 3 here. So you can just say 2 pi minus pi over 3 and you'll get where this point should go to. But I'm telling you, the easier way to do this is the trick I'm getting ready to show you. Whenever we have something in with sine or cosine, and I want to get rid of this now. But whenever we have something with sine or cosine and we're looking at this in the parentheses, and it's not just x by itself, then we need to do this little trick right here. We're going to take whatever's in the parentheses and set it equal to 0 and solve for x. I get negative pi over 3. Take again what's in the parentheses and set it equal to 2 pi and solve for x. So this one requires a little more work. We know that 2 pi is the same thing as 6 pi over 3. That's just getting the common denominators. So x equals 5 pi over 3. And now I've got what I need to set up my x-axis. I'm going to go to somewhere over here and let it be negative pi over 3. And so there's my negative pi over 3. Let's get that out of the way now. And then over here I need to let somewhere be 5 pi over 3. And I'm going to get rid of my little math work down here now. So all I did to come up with those 2 points is set what's in the parentheses equal to 0, solve for x. That's what I got. Set it equal to 2 pi, solve for x. That's what I get. It's what you do every time. Set it equal to 0, set it equal to 2 pi. Then we got to come up with all the 3 points that are in the middle here. So a moment ago I told you how to do that. You take the two ends, add them, and divide by 2. What's negative pi over 3 plus 5 pi over 3? Well, that is 4 pi over 3. That's just adding them. Now you got to divide it by 2. Dividing by 2 is the same thing as timesing by 1/2. So really what I'm doing is just doubling the denominator there, but I get 4 pi over 6, which is the same thing as 2 pi over 3. So exactly halfway between here is going to be 2 pi over 3. And I still got to come up with a halfway point between here, these 2 points, and the halfway point between these 2 points, using the same method. Take negative pi over 3 plus 2 pi over 3. I get pi over 3. Times that by 1/2, I get pi over 6. So this point's pi over 6. Find the halfway point between these two. Give myself a little room here. So I got 2 pi over 3 plus 5 pi over 3. That's 7 pi over 3. Times that by 1/2. That gives me 7 pi over 6. So these are not as fun, these phase shifts. And there are other ways to do it. You can look them up. I find it easiest because in a moment when we put a number in front of the x, we can take care of a lot of transformations very quickly using this method. Now, what's the amplitude on this? Are there any vertical shifts? Those are other things we have to pay attention to. Because I just want to teach you phase shift right now, I didn't do any other transformations to it. I'll try to keep it as simple as I could. So the amplitude is still 1, and there is no vertical shift here. So I just say, what's the sine of 0? Well, the sine of 0 is just 0. So I'm just basically following this same pattern here. We go here, then you go to the maximum value. Let's say this is 1 and this is negative 1. So up here's 1, then down, then back up. Notice I don't have to put in 0 and say, okay, 0 plus pi over 3 is pi over 3. What's the sine of pi over 3? Pi over 3 isn't even listed here. It's kind of like I'm saying, what makes the parentheses equal to 0? Well, negative pi over 3 is. So that would give me the 0 here. What makes this equal to the next one, pi over 4? Not pi over 4, pi over 2. I guess pi over 6 would. And so that's where I'm going to get the 1 and so forth. But I think it's much less thought you have to put into it, which means there's fewer mistakes you're going to make if you use this method right here. Once again, that method, take what's in the parentheses, set it equal to 0, solve for x. Set it equal to 2 pi, solve for x. Put those points graphed right there. Find the halfway point between the 2 points. Find the halfway point between these 2 points. Find the halfway point between these 2 points. And then you can just set your pattern off like that and sketch your line. Okay? Let's look at another one. Let's do y equals the cosine of x plus pi. Actually, let's not do pi plus. Let's do a minus, just so we see a different shift here. Minus pi. So once again, I know this is going to shift to the right. The parentheses are not just, they just don't have x in it. So usually, if it's just x, well, you set what's in parentheses equal to 0 and 2 pi and solve for x, and boom, those are your values. But it's not just x. So I need to set what's in the parentheses equal to 0 and 2 pi. And so it's going to be x minus pi equals 0, and x minus pi equals 2 pi. So this gives me x equals 3 pi, and this gives me x equals pi. And so that's where we're going to start. We're going to start at pi, and it's going to go to 3 pi. Is that where you need to start your graph? No, you just need to show me one period. So if you do it a different way and it works out, that's great. You might want to come and check with me, make sure it's good with me, but I don't really care if you do it a different way as long as it's the same graph. Pi plus 3 pi is 4 pi, divided by 2 gives me 2 pi. Pi plus 2 pi is 3 pi, divided by 2 gives me 3 pi over 2. 2 pi and 3 pi give me 5 pi. Divided by 2 gives me 5 pi over 2. So there are my 5 points. Once again, what's my amplitude? My amplitude is a 1. There is no vertical shift. So I know that the cosine of 0 is 1. So if I let this be 1, this is negative 1. It starts up top. It goes down. It goes down below. It goes back up to the top over here. So your graph looks like this right here. All right. And once again, notice these are going up in a certain increment. If you follow that, you could continue on following points here and take it back down and so forth, and same way this way. I just want to see one full period. Okay. Let's look at one that's a little bit more complicated. Actually, I won't make it too complicated. I'm just going to do it like this. I'm going to say, what if we had the y equals the sine of 2x. Now, be careful here. This isn't an amplitude change. The amplitude change would be if the 2 was right there, like if it were y equals 2 sine x. I don't have that going on. I've got y equals the sine of 2x. So if you do the method I told you again a second ago, I say what's in the parentheses, set it equal to 0, and solve for x, and then set it equal to 2 pi and solve for x. What do we end up getting here? Well, we get x equals 0 and x equals pi. And so when we go to graph this, let's draw our line here. Our period goes between 0 and pi. So right here is 0 and right here is pi. And so halfway between there is pi over 2. Halfway between here is pi over 4. Halfway over here is going to be 3 pi over 4. And so as we do this, we're going to say, okay, sine starts right here in the middle. It goes up, down, down, down. Remember, the amplitude here is 1, so this is going to be at 1 and negative 1, what it's bouncing between. And it looks like this. This is one period. The baby's got the hiccups. I don't know, it's rough, isn't it? So if we compare this to the sine of x, the sine of x goes from 0, now x equals 0, to x equals 2 pi. So right here is 2 pi. Halfway between's pi. Halfway between's pi over 2. And then over here is what? 3 pi over 2. So it starts in the middle, goes to the top right here, to the middle, down below, and back up to the top. So what's in blue is in the sine of x. What's in graphed in green is the sine of 2x. Notice the sine of 2x could continue on like this. It actually, let's go back. It has a halfway point here and here that it goes up to, back down, down below, and like this. It actually completes 2 cycles between 0 and 2 pi. And then the sine of x completes only 1 cycle between 0 and 2 pi. And so this is where we get that horizontal stretch or compression. In this case, it's a compression. Notice it fits 2 cycles in between 0 and 2 pi. Let's skip over to Desmos and see how this pattern might work out. So I'm going to go back to the sine function here. And I'm going to put a slider. Actually, we can just, let's graph sine of x. And if I put a number in front of that, like if I go and put 2 in front of it, notice how it squishes in. And between 0 and pi, it gets 1 complete cycle in. If I put a 3 in there instead, now starting at 0, here's 1 cycle, here's 2 cycles, here's 3 cycles between 0 and 2 pi. So the complete period goes between 0 and 2 pi over 3. If we make this a larger number, like 30, boom, look at 30. There's a lot of ups and downs between 0 and 2 pi there. So it's almost like kind of like a slinky that or a spring that you're compressing when you make that number larger in front of the x there. Now, before we actually see it in Desmos, predict what would it look like if I did 1/2 of x, like sine of 1/2 of x. Let's go back and sketch that out. If we were to do y equals the sine of 1/2 x. To graph that out, remember, set what's in the parentheses equal to 0 and set it equal to 2 pi. And solve for x in each case. So I get x equals 0, I get x equals 4 pi. So now this period here is going to begin at 0 and end at 4 pi. Halfway between is 2 pi. Halfway between this is just pi. Halfway between this is 3 pi. No change in amplitude, so it's going to bounce between 1 and -1. Start at 0, goes up to the middle, down below, back up. And notice if we compare this to just the sine of x comes through, whoops, sine of x comes through like this. So you only get half of a period in, or between 0 and 2 pi versus a full period between 0 and 2 pi with the sine of x. And so as we go back to Desmos and just kind of verify that, if I were to change this to 1/2, what does it look like? 0.5. Oops, I deleted my n there. Notice that's only half of a period, and there it is ending at 4 pi there. Let's put a slider in just to see, because they're fun to do, right? Add a slider, and now we can see how making it negative. Notice a negative large number still scrunches it. It's between 0 and 1, a fraction that spreads it out. A fraction between 0 and 1, that is. But the absolute value there is going to scrunch it in no matter which way you go there. So it's pretty cool. You can check that out, play around with it with Desmos to make sure you fully understand how that transformation there works. So what have we talked about with these things? We said if we have y equals a times the sine of something, this a is an amplitude. Let's start on a new page here. Y equals a times the sine of, let's say we've got bx plus c plus d on the outside here. This a is our amplitude. That's an m. This d is our vertical shift. This c is what we call a phase shift. It's really the same thing as a horizontal shift. And this b right here changes our period. All right. The way I want you to approach graphing them is to set what's in the parentheses equal to 0 and 2 pi. Figure out where those 5 key points are on the graph. All of these graphs are going to have 1, 2, 3, 4, 5 key x values. Find those by setting these between equal to 0 and 2 pi. That will give you the ends. And then you can, oops, Fake the binky. There we go. Halfway between these 2 points, you'll find this one. Halfway between these two, you'll find this one. Halfway between these two, you'll find this one. Then you can say, all right, before you actually graph it, change the amplitude, and then shift them up and down like you need to. Let's try one before we end here that does all of those things. So let's do this one right here. Y equals 3 times the cosine of 2x plus pi minus 1. So first thing I note is, all right, I'm going to have to shift everything down 1, and the amplitude's changed to 3. So this thing, originally if I weren't shifting down 1, it would bounce between 3 and negative 3. But since I'm shifting everything down 1, it's going to bounce between 2 and negative 4, just because everything gets shifted down 1. We'll look at that in a moment. What I really want to do is find out where are those 5 key points there. So I'm going to take what's inside the parentheses and set it equal to 0. And I'm going to set it equal to 2 pi and solve for x in both those cases. So solving for x, you're going to get negative pi over 2 equals x there. And over here we're going to get, let's see, subtract pi, divide by 2, you're going to get pi over 2. So let's graph this out. Now I've kind of made this a little bit different just because I know I'm shifting it down 1. I probably don't need to make my x-axis that high up. But I know I'm going to go from negative pi over 2 to pi over 2. Now it should make sense that this goes to the left because we're adding pi. So it's going to shift everything to the left pi amount. You might say, well, if it shifts at pi over amount, how come it's not at negative pi? It's because this 2 in front of the x, remember, changes the period. So it messes several things up. But the nice thing about doing this method is it takes care of both of those transformations in one step. Now I'm going to find the halfway point between negative pi and pi over 2. Well, add them up, and you get 0. Divide by 2, I'm right here at 0. So that's the halfway point. The halfway point between negative pi and 0 is going to be adding those two up. Well, negative pi over 2 plus 0 gives me negative pi over 2. Times by 1/2 gives me negative pi over 4. So right here, halfway between, make it negative pi over 4. Likewise, 0 plus pi over 2 is pi over 2 times 1/2 is pi over 4 right here. And so if I didn't have this minus 1 and 3 here, I could just start at the top and draw my graph going through there. But I do have a 3 and I do have a minus 1 there. So it's like I'm going to take a dashed line right here. That is my x-axis. I'm going to go up 3. I'm going to go down 3. And normally, my graph would look like this. I would say, okay, I'm going to start at the top. I'm going to go down like this. I'm going to hit down below, and then go up like that. That's without the minus 1, but with an amplitude of positive 3 and negative 3 right here. But instead, because of that minus 1, I have to shift everything down 1. So let's shift it all down 1. So this would become minus 4. This would become minus 1. This would become 2. So everything gets shifted down 1. And so does your graph. Your whole graph gets shifted down 1. I probably didn't do that to scale. There we go. There's our minus 4 right there. And so there's your graph. This should be at, just so you know, this point is at negative pi over 2, comma 2. All right. Well, that's probably my longest video yet. And sorry about all the baby hiccups in between. It's just I'm doing what I can to make all this work. I know it's a lot to take in, so hopefully you kind of broke this video up into a couple segments on your own, whatever's manageable for you to digest. I'll be, you can ask me questions in class if you have me as your teacher, and I'll be happy to answer those. Watch the videos a couple times if you can stand it. And hopefully, though, this made graphing trig functions a little bit bearable or easier for you. Okay? Let me know if you have questions, and thanks for watching.